So today we're going to look at what are called parametric equations, which are another way to represent points in a plane, which are actually connected by a third variable or parameter, which is why they're called parametric equations. So you should be able to plot points if I give you a set of equations, and then you should be able to eliminate it and put it back into function mode. Okay, so we can think about it this way. If you think about the plane that your home is in, assuming it's a one level, so one level of your home, and that's a plane, and as you move through it, if you look at the blue and the brown and the black as being different people's paths, if you look at it one way, you could think there's a collision in the doorway to the kitchen where they're all in that same place. And the graphs represent where you are in the plane of your house, but parametric equations introduce a third variable, which is the time that you are in that spot, so that three different people could travel those three different paths and yet not hit in the doorway to the kitchen because they're there at different times. Okay, so we're going to start with, here's our first example, and parametric equations will look like this, where they have a set, an x equals equation and a y equals equation, and both of the x coordinate and the y coordinate are given in terms of a third variable, which is t, often representing time. Okay, so now to graph this, we still get the points. So now our input for both is now x, there's t. So we input t into this equation right here and can get x coordinates. And sometimes they'll give you bounds for your input, sometimes not. We're going to do ones where we're going to start at a certain point and end at a certain point. So we're going to start at t is -2. When t is -2, if I put it into this equation up here, I get -2 plus 1, and that's going to be 1. And then if I put that same -2 into this equation, into the y equation, I get the absolute value of -2, which is 2 minus 1 is 1, which means that I have this xy point of 1, 1, and that is where I am at time t -2. So I can try another time. When t is -1, again, I go back up to the x equation. -1 plus 3 is now 2. And when I put -1 into the y equation, absolute value of -1 is 1, minus 1 is 0. So from this point at 1, 1, I've gone to the point 2, 0. Okay. Let's try another one. At time 0, the x coordinate is 3, the y coordinate is -1, so that's going to be somewhere right here. Right, at time 1, my x coordinate is now 4. My y coordinate, though, is back to 0, which is interesting. And at t equals 2, my x coordinate is 5, and my y coordinate is 2 minus 1 is back to 1. Okay. And so if I connect these points, it looks like they're sort of linear, and I can connect them. Here's my graph. The thing that's going to be different about this graph than a y equals graph is we are going to put little arrows which sort of show the direction that we traveled this path, right? Because I started at t equals -2. I started right there, and then I went towards the right, right? So there's our graph for that parametric equation. And this is just, it's on a limited domain. We're only looking at these times. I think you could guess that the graph would continue, but we haven't looked at that. Okay. So now if I have this equation, the set of parametric equations, if I know one of the three variables, because every point on this graph really has three things. It has the x coordinate, it has the y coordinate, and it has the time or the t associated with being in that location. So if I know any one of the three, I should be able to find the other two. So we can ask you questions like, find the y value when x is -12. This is just substituting. So I make my x, I'm going to look at this equation right here. When x is -12, well, that happens, I solved this equation for t. So I'm going to subtract 3 from both sides. So x is -12. When t is -15, to find the y, I'm going to take that t of -15 and put that into this equation. And so I'll say my y is the absolute value of -15 minus 1, or y is, in this case, 14. Okay. I can also find x when y is 8. So it's something similar. I'm just going to say, well, I know that y is 8, so I make y 8. Then I'm going to solve. I'm going to add 1. Now, how do you undo absolute value? Well, again, when the absolute value of something is a number, then that thing, the thing inside, so t is either 9, that's obvious, or it could also be -9. So if I took the absolute value of -9, I would also get 9. So what that means is that I'm going to get two possibilities for x, because if t is 9, then x is 9 plus 3, or x could be 12. Or if t is -9, I'm going to get -9 plus 3, and I'm going to get or -3 right here. So those are my two possibilities for x. And if we look back at the graph, it kind of makes sense that for a given y coordinate, right, if I know y is something, there are, like when y was 0, there were two different x coordinates. When y was 1, there were two different x coordinates. So it shouldn't be that unusual to think that this would happen. Okay. Another thing we can do with this is we can turn this parametric equation into a y equals equation. This is called eliminating the parameter, right? Rewrite as one equation with y in terms of x. So to do that, we generally will take our y equals or take our x equals equation and solve it for t. So I have this equation right here. If I want to solve it for t, I could say x minus 3 is t. And now I can replace t in my y equation with what I just found, which was x minus 3 minus 1. And then we want to show that this is the same graph we got when we graphed it point by point. Well, if we think about this right here, you should recognize that as a parent function of a absolute value. So we have our V-shaped graph. We have shifted it to the right 3 and down 1, right? So we have this vertex right here, and the absolute value is up 1 over 1, up 1 over 1 in both directions. Boom. And that, I mean, here we would go on forever, but if you look back at what we found point by point, it is the same graph. Vertex at 1, 2, 3, -1, slope of 1 both ways. And that's called eliminating the parameter. So there you go. We've done something with parametric equations.